Welcome, math aficionados. This is Victoria, and this is section 7.2, which is on rational exponents. You're going to see that starts in your textbook on page 442. And where I'm going to direct your attention to is actually the top of page, let's find it, here, the top of page 446. And you're going to see rules for rational exponents. Okay, you need to know these. Okay, you need to commit them to memory, and you need to know when to use them. And I'm going to go over these rules, and then I'm also going to do a couple examples in this video, and hopefully that will make you successful in the quiz that you have for this week. That's going to be quiz 10. So here they are. Okay, let me take a look at what I have over here. So beware. Beware is what I'm saying. You need to know your laws, right? Okay. So here are some of the rules. One of the rules is called the product rule. And in the product rule, if you have like bases, here you see an A and an A, and they're both raised to an exponent, you can simplify that by taking the A to the R plus S. So in simpler words, if you have like bases, you add the exponents. Add the exponents if the bases are like. Now, here's the case where you have like bases, A, and you have exponents R and S, and I'm dividing. When you are dividing with like bases, then you subtract. You subtract the exponents, okay? Ooh, okay. Now, this one is called power of a power. If you have inside of parentheses a to the r power, and outside those parentheses you have another exponent, to simplify this, the law says that you multiply. You get the product of those exponents. So when you have the power of a power, you multiply. And this is kind of goes along with the next one, where if you have two things inside of that parentheses, they both get raised to that power. So we're going to multiply when we have power of a power. And this one says that if you have a product, if you have a fraction, then and everything inside of there is raised to a power, then you can raise the power to each one of those things in the quotient. So a to the r over b to the r is the same as a over b all raised to the r power. Okay. Hopefully you're familiar with these and you will be comfortable as you do some problems. Now I'm going to add on a couple rules. I'm going to talk here about rational exponents, and the term rational is a fancy word for fraction. So what do we do when we have an x to a fraction, x to the 2/3 power? Well, we're going to translate that to be equal to, it's going to have a radical, and the x is going to be raised to the second power, and it's going to be a cube root. So the way this works is if you have this fractional exponent, the number on the top becomes the thing that we're raising it to, the exponent we're raising it to, and the number on the bottom in the denominator becomes the index of the radical. Okay, so it's very important to know that. Here's another case where I have y to the 1/2. So if I have y raised to the 1/2 power, ding, 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 I've got a fraction. I've got a rational exponent. I'm going to think radical. The y is going to go on the inside. And this 2, this is a y to the 1 power. The 1 on the top tells you the exponent, and the 2 tells you the index. We don't usually show a 2. We know the square root, but for this example, I'm showing you that. So there's another law that you need to be aware of. And I just wanted to show you down here as a good example that if we have a, if we have a to the m over n power, sometimes it's more convenient to take the m, the numerator can be on the inside, so we can write the numerator on the inside of the radical, And sometimes it's more convenient to write it on the outside of the radical. It doesn't matter. So you could take the nth root of a and then take it to the nth power, or you could take a to the nth power and then take the nth root. Good to know. Again, you need to have all of these laws committed to your memory. What about if we have a negative? What about if our exponent is negative? Well, that's easy. We're just going to rewrite that as 1 over. So if I said I've got y to the negative 4, we can rewrite that as 1 over y to the 4th power. Okay, if I have x to the negative 10, that's just going to be 1 over x to the 10th power. Excuse my sloppy writing. And if I have x raised to the negative 2/3, no problem. We can rewrite that as 1 over x to the 2/3 and get rid of that negative power. Okay, all ways to deal with that negative exponent. And one thing that I don't know if the book includes this or not, but it's a good thing to know. And the final law says anything raised to the 0 power is 1. Anything raised to the 0 power, anything raised to the 0 power is equal to 1. So that's a definition, not really a law. It's how we define it. So those are the rules that we absolutely have to have. Okay, those are the things that we have to have. And then the fun part begins. The fun part is applying these rules and solving these problems. So what I've decided to do here is just to go ahead and do a couple examples with you. Do just a couple examples so you can see what you're up for, what kind of fun you're in for. So here's 2 examples on this page. I've got 6 to the 4/3 power and 6 to the 2/3 power. So I want you to recognize here I've got like bases. I've got a 6. So if I have like bases and I'm multiplying, what I'm going to do is I'm going to add exponents. So I'm going to have 6, add my exponent 4/3 plus 2/3, right? 4/3 plus 2/3. Like bases, add the exponents. So I'm going to get 6 to the 4/3 plus 2/3 is going to be 6/3 power. Because I added 4 plus 2 is 6. Keep my denominators. And that's really equal to, that's not in lowest terms, that's going to be 6 squared, which I can finally simplify as 36. And that is your answer. So I can take this particular problem and I can start by recognizing the like bases. Then I can add the exponents. Remember, when you add fractions, you keep the denominator and just add the numerators. Then I can go ahead and simplify and get this final answer. And the next example that you'll see at the bottom of this page is one where we have like bases, z, and we also have different exponents that it's being raised to. So let me go ahead and solve this one for you. So again, I've got the like bases here. So I'm going to rewrite z, and I'm going to keep the 3/4 on the top. But I need to subtract the exponents. Like bases and divide means subtract, so it's going to be 3/4 minus 5/4. And then also minus a -2. So now I just need to clean up my exponent and I'll have this solved. So it's going to be z raised to the 3/4 minus 5/4. And let's just write this as minus and minus is going to be a positive. And let's put it in fourths so we can add everything up. And so 2 is going to be equal to 8/4. 2 is going to be equal to 8/4. All right, so come down here and we're going to rewrite this as z is equal to 3/4 plus 8/4 is going to give me 11/4 minus 5/4. All right, or I'm going to get as an answer z to the 6/4. And just recall that that's not in lowest terms, so I'm going to rewrite that as z to the 3/2 power. And that is your solution to this particular one. So remember, when you're doing these problems and you're looking for like bases, if you're dividing, you're going to subtract. If you're adding, if you're multiplying, you're going to add. And just follow your nose and reduce the fraction till you get your final answer. Now, I do have one more example, and there's a couple of these like this in the homework, so I'll take the time to go over one more example with you. And I'm going to use what I call the distributive law. I have z raised to the 5/8 times this binomial, 3z to the 5/8 plus 5z to the 11/8. So we're going to distribute this z to the 5/8 to both terms. So it's z to the 5/8 times 3z to the 5/8. That's the first term, plus z to the 5/8 times the second term of the binomial, 5z to the 11/8. So all I've done so far is just distributed what was outside to each term in the binomial. Now if you look at this, I've really got two different products and they both have like bases, so I'm going to add those exponents. So I'm going to have 3 times z to the 5/8 plus 5/8. And then I'm going to have 5z to the 5/8 plus 11/8. All right, and let's simplify further. So 5/8 plus 5/8 is 10/8. So I've got 3z to the 10/8 here, plus 5 times z to the 5/8 plus z to 11/8 is going to be z to the 16/8. Almost there. One more step and we'll be done. 10/8 isn't in lowest terms. I can divide both of those by 2 and I'll get 3z to the 5/4 plus 5z, and 16/8 I can write as 2. So there you go. There are a couple different examples. You'll see some of these as you do your homework. Good luck. Practice, practice, practice is the key. Look forward to more videos by me, Victoria. You'll see them next week on 7.3 and 7.7. Bye for now.